I would like to introduce our natural language interface for relational databases, also known as NL-to-SQL. Nowadays, everyone is used to asking Google to search for any information in their own natural language. However, it is challenging to search in a relational database system with natural language, since relational database systems only support the structured query language, also known as SQL. So on the right side, you will find a simple example of a natural language question and the corresponding SQL query. For someone who knows SQL, writing queries seems straightforward, but this is definitely not easy for someone who doesn't know SQL. Thanks to advances in deep learning, we can generate SQL from a natural language question. The flowchart on the right side shows the pipeline of ValueNet, which is built on top of a transformer-based neural network, which is a state-of-the-art pre-trained deep learning language model that can understand the real question. As you can see in the pipeline, we start with the natural language questions, database schema, and the content of the database. This content goes through a pre-processing step and is then fed into the neural network. Then, the neural network outputs an intermediate language SQL, a kind of abstract syntax tree to describe the corresponding SQL. The SQL can then be deterministically translated into SQL in post-processing. The final product is a SQL query that can be executed against the target database. So we applied the ValueNet on the Kosten database. Kosten database involves a domain of policy with project and asset management. Its data schema shown on the right side holds 19 tables and 90 columns in total. The challenge of applying ValueNet to this real-world database is how to produce training data in an effective and economic way. We did a series of experiments to discover the impact of data augmentation quantitatively. Here are 3 configurations of experiments in which they share the same test data but applied with different training data. After conducting the experiments, we found out that data augmentation significantly improved the performance of the NL-to-SQL system. So let's dive now into a simple example to review the implementation of data augmentation. So here is an example of the handmade test data. The question is, what are the titles of all projects that start before 2018? The corresponding SQL query is written underneath. So together with a diagram of the relevant relations, this query could not be successfully translated before data augmentation, since there exists a similar attribute to start year that is called start date, which confused the model. The problem is we cannot add this natural language and SQL peer example directly into our training set while it is a part of the test set. Of course, we solve this issue with data augmentation. So you can find in the screenshot on the right side that shows a successful prediction. Our approach is to generate new data samples synthetically. The principle behind the data synthesis is straightforward. We abandoned the original natural language question and shuffled a part of the SQL query from less than 2018 to greater than to or equal to 2018. Then we conducted an SQL to NL generative model on the shuffled SQL query to get the new natural language question. Finally, we obtained a new training data sample. Of course, it is no surprising to see that the model is now able to produce the correct SQL query because the model is now familiar with the start here attribute. SAMQL is a context-free grammar used as an intermediate representation of a SQL query in the ValueNet pipeline. Last but not least, we have extended the SAMQL grammar, so the green highlight plots, so that it now supports simple mathematical operators in attributes. For example, it can describe an area as length multiplying width, or a period of time as a difference between the end year and the start year. That's all about our natural language interfaces for relational databases. Now, we will show you a short demo video of ValueNet in action in the inode Intelligent Data Exploration interface.
Welcome to the inode Intelligent Data Exploration page. Today I'm going to be demoing our natural language to SQL tool. But since I'm doing the first demo, I'll actually give you a little bit of an overview of what we have on this page. So here you can see this is where you can start your natural language search. Over here we have the search by query builder, but that will be shown in a later demo. And then over here to the right, you can see we have the Kosten database, and if you click down, you have the other databases that you can query. And these, of course, are the databases from the use cases that you've just heard about. We have a little bit more information about each individual database. So today, I'm going to be demoing the Kosten data, which is the EU research projects data. But we also, of course, have the astrophysics and the cancer research data available to query as well. If we go a little bit further down, you see that we have some example queries. So if you came to the page and you weren't really sure where to start, these are some queries that you could use to get you started in your research. So let's get started with the natural language to SQL. So we're going to search for the query. We want to find the starting year of projects with the title inode. We can start our search. Okay, so you can see we have 3 different results. So let's have a look at the first one here. And we can see that the SQL query that was returned in the projection, we have the start year. We can see that we're selecting from the projects table, and we have a nice filter on the title column, and we're looking for the project called inode. And we have the start year you can see is returned here, and indeed the project was started in 2019. So this query gives a good result. You can also see that you have another natural language interpretation here. This is actually SQL to natural language, but that will also be discussed in the next demo. So this is rather a simple query. We just had one projection and a simple filter, but let's go back and see what this system can actually handle. And let's have a look at one of the queries that we have prepared down here, the institutions and the sum of the EC contribution in descending order. And let's run this query as well. And here you have again the SQL to natural language explanation. And if we click down. All right, so we are looking for institutions and the sum of the EC contribution in descending order. So indeed, we have selected the institution's name, and we have a sum on the EC contribution column. We also see that this query is a little bit more complex because we already have an aggregation. And we are selecting from 2 different tables, the institutions table and the project members table. Of course, if you have an aggregation in the projection, the other column needs to be grouped. So we have correctly a group by on the institution's name. And we also asked to provide these results in a descending order. So we have the EC contribution in an order by and also descending. So this query looks good. And we can see here we can see here we have some headings over here, so some some words that are interesting. We also have content from the columns displayed in a word bubble over here. Additionally, because this is a sum, we're able to see it in a graph form, and we can get a little bit more information from it when we roll over the image. So you can see here as well, we have the column details. So these are all of the institution's names. Okay. So thank you very much. That's it from me, and I will hand you off to the next demo.